Okay, so welcome dito sa ating YouTube channel. Ito yung lesson 16 sa ating set theory. So this is all about countable sets. Okay, so before that, pag-usapan natin itong mga definition. So dapat ito yung gagawin nyo. Intindihin nyo lahat ng definition, kailan tatawagin yung theorem. So para mas mapaikli natin yung proving. So pagturo ko sa inyo, ipapakita ko sa inyo kailan nyo gagamitin, kailan nyo tatawagin yung mga ganun scenario. At least mababawasan yung haba ng proving natin. Okay, so definition. So let A be a set. So tandaan na, let A be a set. So it's either non-empty, empty, empty, finite, or infinite sets. Okay, so number 1. So definition number 1. A is said to be countable if A is finite or A is numerically equivalent to natural number. So pwede kong palitan yung natural number na yan. So pwedeng Z plus. Okay, si natural numbers of Z plus ay equivalent sa isa't isa. Okay, so ulit, A is said to be countable if A is finite. So meaning, nabibilang mo yung laman. So tandaan mo yung word na countable. So we say that A is countable. Una, if A is finite. Meaning, kaya mong bilangin. Next, if A is numerically equivalent to natural number or the set of positive integers. Ano ibig sabihin pag numerically equivalent? So redefine ko lang to. Pwede mo sabihin countable siya. A is countable. Countable if there exists a function f mapping from our A going to the set of natural number that is a bijection. Okay, kasi ang ibig sabihin nga na numerical equivalent, there is a function mapping from A to N or A to natural number that is a bijection. Yun ibig sabihin. Another way, pwedeng sabihin natin na A is countable if A is strictly less than to N and N is strictly less than to A. Okay, so kung naalala nyo, ano ba ibig sabihin ng strictly? Strictly means A is strictly to N, meaning there exists a function mapping from A to N that is 1 to 1. Also, there exists a function mapping from N to A that is also 1 to 1. Then by Schroeder-Bernstein, pwede natin sabihin na siya ay numerical equivalent. So maraming way para masabi natin, pero ito lang yung isa sa sigurado ko. Para masabi mong countable, dapat may mag-exist na bijection mula dyan. Okay, so tanda mo, a bijection from A going to natural number of or positive integers. And ito nga yung sabi, ito nga yan. So sabi ko nga, pag nasabi mo ng ganyan, ito ibig sabihin, if A is numerically equivalent to N, o meaning may nag-exist na function such that mapping from A to natural number, we say that A is countably infinite. So ngayon, ito lang yung magiging dating. Si countable, para masabi mo yung set ay countable, it's either siya ay finite or countably infinite. So ito yun, A is countable. Okay, dalawa yung ating pagpipilian. Una, finite. Okay, finite si A, meaning countable siya. Pangalawa, countably infinite. This is countably infinite. So, pansinin nyo, no? Sa pangalan pa lang, nabibilang pero infinite. Okay, yun yung term para sa isang set na kung saan nag-biject or nag-bijection sa Z plus or sa natural number. So, kung nagkaroon ng bijection o nagkaroon ng function na bijective mapping from your set to natural number or Z plus or positive integers, therefore, we can say that A is countably infinite. So, ibig sabihin lang, nag-map siya sa lahat ng element ng natural number. Tapos, 1-to-1 correspondence or bijection siya. Okay, so yun yung other term. So, ulitin ko lang, countable ka if finite ka or countably infinite. Countably infinite ka if merong bijection na nag-exist mapping from A to natural number or Z+. Yun yung ibig sabihin. That is definition number 2. So, meaning ng definition number 2, ito mismo. Okay, next, number 3. If A is uncountable, A is uncountable if A is not countable. Obvious naman. Okay, so ngayon, sir, ibig sabihin, sir, yung infinite, kunyari tulad ni integers, So pag napatunayan ko po sir, or nakahanap ako ng function na nagmamapping going to z plus, therefore siya po ay countably infinite or countable. Yes, countable siya in a sense na hindi mo man alam yung lahat ng laman, pero sigurado kang countable siya kasi mayroong bijection. So special term to dun sa mga infinite sets. So sa infinite sets may dalawang klase kasi. So later on malalaman mo, okay, yun yung pinagkaiba niya. Infinite pa rin siya, pero may term lang tayo na tinatawag na ito countable, itong kabila is uncountable. Kasi dito natin malalaman kung gaano karami, or I think hindi man natin masabi kung gaano karami, hindi naman alam yung bilang kasi parehas pa rin naman, infinite yun naman. Pero ang sure lang natin, countable siya in a sense na, ayan nga, dinidefine yung term na yan. Ito naman yung mga importante dyan. Okay, so sabi nga no, A is uncountable, ulitin ko lang, if A is not countable, and that is A is not finite and A is not numerically equivalent to natural number. So ibig sabihin, hindi siya finite. Pangalawa, wala nag-exist na bijection mapping from A to natural number. Okay, such that it is countably infinite. So, ganun lang siya kasimple. So, ibig sabihin lang, dalawa lang criteria. Hindi siya finite, walang bijection na nagmumula doon. Okay, so next. So, before ko sagutan yung example, as sabi, the set of integers is countable. Before ko sagutan yan, let's have theorem 1.1. Kasi gagamitin ko yan, tatawagin ko. So, sabi, tingnan nyo let A be a non-empty set. Then, the following are equivalent. Ano ibig sabihin ng equivalent? Mamaya, tapos natin. So, number 1, A is countable implies there exists a surjection F mapping from N to natural number. Ang ibig sabihin ng equivalent, meaning, yung 1, 2, 3 na yan, pwedeng ganito. Assume ko si 1. So, kunyari, assume ko si 1, kuha ko si 2. So, for example, sure ka na si A is countable by theorem 1.12, there exists a surjection F mapping from natural number. Yun ang ibig sabihin. Kunyari lang if A is countable in assume, then there exists a surjection F mapping from N going to A. So, mapping from natural number to A. Automatic yun. Next, pangalawa, this is 2 implies 1. 2 implies 3, sorry. Okay, so if there exists a surjection, so kung nakita ka naman ng surjection mapping from N to going to natural, mapping from natural number to A, there exists an injection naman, G, mapping from A going to natural number. So, assume ko, show. Okay, or kung nakuha mo na yan, meaning, right away kuha to. Yung ibig sabihin ng equivalent, so ito yung kagandahan ng theorem na to. So, tulad nga nun, kung countable na siya, conclude na to, kuha ko na to. Kung mayroong surjection, conclude ko na to. And lastly, 3 implies, this is 3 implies 1. Okay, so kung mayroon naman injection from G mapping to A to natural number, okay, so G going mapping from A to natural number or Z plus, therefore, kunyari pag mayroong surjection na ganyan, sorry, then therefore ito agad, automatic, baliktad no, if there is an injection mapping from G going to A to natural number, therefore A is countable. So kung mapatunayan mo lang na injection siya, automatic countable ka na by theorem 1.11. Okay, basta mapakita mo. So anong gagawin natin lagi usually? Ang pinakamadaling way para ma-prove natin ng isang set na countable, humanap ka ng function, tapos i-map mo lang siya going to natural number, tapos i-prove mo lang na siya ay injective. Then by theorem 1.11, okay, A is automatic countable. Ganun kasimple. Okay, ngayon, yun yung gagawin ni sir dito. So, the set of integers is countable. So, ang gagawin ko lang, syempre, mag-i-introduce ako ng function, tapos ang goal natin, i-prove natin na siya ay 1 to 1. Then by theorem 1.11, kasi nga, dahil siya ay injection or 1 to 1 na, okay, na mapping dun sa ating N, therefore, A is uncountable. Or therefore, the set of integers is countable. Ngayon, kung siya ay countable na, tapos na tayo. Okay, so ngayon, ito na yung tanong. The set of integers is countable. So, kung mapapaisip ka, sir, ano pong klaseng function yung gagamitin namin para ma-prove na yan ay countable? So, by the way, what is the set of integers? So, the set of integers are yung number na positive and negative natural number including yung 0. So, ito yung negative 3, negative 4, negative 1, negative 2, 0, 1, 2, 3, 4, something. Okay? So, ngayon, Ang gagawin sir, ito yung proof. So another thing, so ito sir, saan galing yung function mo? Kagaya ng paulit-ulit kong sinasabi, hindi ko yan hinulaan, hindi ko yan basta-basta kinuha lang. So ako talaga, meron din naman ako reference, hindi book. So I think, sabi ko nga sa inyo, technique, no? Since ang goal ko kasi is set of integers, alam ko integers yan eh. So aware ako na integers yan. So ang goal natin para maging, dahil infinite yan, so aware ka, si integers infinite. So hindi na pasok tayo sa criteria na finite siya. Tama? So therefore, si integers hindi na finite, hindi natin pwede sabihin countable siya. Okay, ngayon, ang goal natin, kailangan makapagpakita tayo ng countably infinite or yung mapping na from A to natural. Yung A is numerically equivalent to natural number. Yun na yung goal. So, ang pinaka-goal natin talaga, napakita natin to na A is numerically equivalent to the set of natural number, o yung integers is numerically equivalent to the set of natural numbers. So, meaning, sa proof, pag ginawa na sa rin proof, okay, so lagay ko lang dito yung proof. Okay, so ang goal natin, gagawa tayo ng function. Okay, so let f be a function. Okay, mapping from my z, kasi yun yung integers ko, going to the set of natural numbers. Okay, pwede rin yung ganito. So kung di ka sanay sa natural numbers, pwede rin mapping from f going to z, going to z plus. So sa other book talaga z plus yung gamit, pero ako natural number na lang, kasi sa natural number talaga unique dyan eh. Okay, kumbaga parang copy lang, parang although parehas si z plus saka si n, pero kumbaga in terms of pagkaka-discover ng mga number, mas nauna talaga si natural number. Okay, so ito lang yung ginagamit ko. So ito, ang goal ko, humanap ng function mapping from z going to natural number. So yung mga domain ko, integers, nandiyan yung negative 4, negative 3, 0, tas positive. Ang goal niya, humanap pa ng function na pag sinubstitute ko, nagiging positive natural number lang, or positive integers lang. Ganun yung gagawin natin. Okay, so let f be a function mapping from z to n. So defined by ito. So ito yung nakuha ko, f of x is equal to the piecewise function of 2x plus 1 and negative 2x whenever x is greater than or equal to 0, whenever x is less than 0. Okay, ngayon isipin natin ano yung mga input. So sabi niya, si f of x is 2x plus 1 pag x is greater than or equal to 0. Saan ba galing x? Sa integers. Okay, so meaning, pag 0, 1, 2, 3, 4, 5, 6, 7, 8, yung gagamitin natin na function, 2x plus 1. Pag negative 1, negative 2, negative 3, negative 4, up to negative something na malaki, ang gagamitin natin, negative 2x. So ito yung function natin. So ngayon, ang goal natin, so sabi ko nga, para masabi natin na countable yan, ang atake natin is in theorem 1.1. Bakit? Para hindi na mahaba, kasi sabi ko nga, no, para maging countable, kailangan countably infinite. So kailangan mayroong bijection mapping from A to natural number. So kung bijection, meaning ipoprove ko na bijective na injective at the same time surjective, tapos ako i-claim siya ay bijective. Dahil bijective siya, sasabihin ko na siya ay numerically equivalent. Then by definition na yun, siya ay countably infinite. Then by definition na yun, siya ay countable. Medyo mahaba. Tama. Imagine mo, dumaan ka ng injection, dumaan ka ng surjection, sinabi mong bijective, sinabi mong numerical equivalent, then saka mo lang sasabihin pa lang na countably infinite. Again, countably infinite pa lang yun. Then by definition 1, therefore she is, integers is countable. Ganon kahaba yung magiging proseso. Ngayon, what if gamitin natin yung theorem? Sabi nga ng theorem, kung makapagpakita ka na siya ay injection, na function na injection, mapping from your set going to natural number, then by theorem 1.11, A is countable, or the set of integers is countable. So mas madali at mas maikli. Okay, so proceed tayo dito sa gagamitin ni sir. So sabi ko nga, ang goal ko na lang, ipoprove ko na lang na siya ay 1 to 1 para magamit natin yung theorem 1.1. So since dalawa yung case, since piecewise siya, dalawa yung magiging case natin. Okay, we will show na siya ay 1 to 1 pag 2x plus 1 or x is greater than greater than or equal to 0 or x is less than 0. Okay, so ito yung una, for all x okay, for all x greater than or equal to 0, okay, or let Latin x sub 1 and x sub 2 element ng integers, okay, such that yung x sub 1 and x sub 2 is greater than 0, kasi ito yung case na yun. Consider natin si f of x sub 1. Si f of x sub 1 ay equal kay f of x sub 2. So, tandaan ito yung case 1. Okay, this implies that since greater than or equal to 0 to, this is 2x sub 1. This is 2x sub 1 plus 1 is equal to 2x sub 2 plus 2. Plus 1. Taras din pala. Okay, next is, siyempre, makakancel yan. This becomes 2x sub 1 is equal to 2x sub 2. Then divide both sides or multiply both sides by 2 or 1 half. This is x sub 1 is equal to x sub 2. So, in this case, this is 1 to 1. Okay, so, f is 1 to 1 or injective. Okay, next for case 2. So, for case 2, this is for all x less than 0. Okay, so that is, let Latin sa x sub 1. Let Latin x sub 1 and x sub 2 element ng integers. So, we have f of x sub 1 is equal to f of x sub 2. Okay, and this implies that negative 2x sub 1 is equal to negative 2x sub 2. Kasi less than 0 na siya. Then, divide both sides by negative 2 or multiply both sides by negative 1 half. Therefore, x sub 1 is equal to x sub 2. So, f is 1 to 1. Okay, so in any case, this is an injection or meron tayong function na siya ay automatic injection. Ngayon, since injective na siya, by theorem, so nakita tayo na function f mapping from z to integers. So, since there exists a function f mapping from integers going to the set of natural numbers, which is 1 to 1, okay, by theorem 1.11, okay, z is countable. Okay, and that is done. So, ganun siya kasimple. So, imagine mo, nagpakita lang ako na siya injective, automatic, countable na. At tapos na ako agad. So, napaka-laking tulong na ito. Pero, to be honest, maraming way para ma-prove. Kasi nga, yun nga, pakita mo na siya na surjective din, pero case 1, case 2 ulit. So, yun medyo iiwasan ko. Tapos, so, kung na-prove ko na surjective siya, so, automatic siya ay bijective. Ngayon, dahil bijective siya, sabi ng mga dating definition, automatic siya ay numerical equivalent. Tama. Ngayon, kung numerical equivalent sila sa isa't isa, then, by definition 2, we can say that z is countable, countably infinite. Now, by definition 1, z is countable since z is numerically equivalent to natural number. Ganun kahaba yung magiging dating. Another way, magpakita ka ng function mapping from z to natural number. Pag napakita mo na 1 to 1, pwede mo sabihin, after na ito, pwede mo sabihin na z is strictly less than to n. Tapos pangalawa, papakita ka naman ng function mapping from n to z. Tapos, kailangan makahanap ko ulit ng function na 1 to 1. Tapos, pwede mo sabihin na z is strictly less than to n. Then, by Schroeder-Bernstein, therefore, z is numerically equivalent to n. Then, punta sa definition 2, then punta sa definition 1. So, ganun talaga, kahaba talaga siya. Literal, kung gagawin natin yung mga usual na minuprove natin last time. Okay, so, ito yung tulong ng theorem na yan. Okay, now, let us proceed sa further properties ng countable sets. Okay, so, theorem 1.2. So, these are properties. So, again, theorem 1.21, theorem 1.22, theorem 1.33, theorem 1.24. Ayun yung mga pangalan yan. Okay, so, intindihin mabuti. So, subsets of countable sets are countable. Imagine, So, kung yung kunyari A subset of B, kung si B countable, meaning yung mga subset niya, let's say si A, countable din yun, automatic. So, parang imposible na uncountable yun. Okay, so ulitin ka lang ha. Kung meron akong A is a subset of B, kung ito countable, kunyari si superset is countable, automatic countable si A. Ganun kasimple. Okay, kaya nga sabi subsets. So, marami yan. So, pag kinuha ko yung power set yan, so marami siyang subset na makukuha. So, meaning, countable lahat yun. Okay, parang imposible. Sir, makakapag-enumerate ba ako ng hindi countable doon? Hindi, automatic countable lahat yun. Kasi countable yung pinakamalaki. Ano pa kaya ako? Okay, number 2. Arbitrary intersections of countable sets are countable. Ano yung sabihin? So, kunyari, meron akong A and B. Kung si A is countable, B is countable. Therefore, yung A intersection B, countable. Ganun kasimple yun. So, sabi nga, arbitrary intersection, hindi lang basta isa. Pwedeng intersection ng tatlong countable pa rin yun. Sir, bakit? For example, sir, paano? Sir, kung wala silang magkakaparehas, ano ba ibig sabihin ng intersection? Pag kinuha ko intersection ng mga set, ang nakukuha is yung common. So, mas malaki yung chance. So, for example, sir, yung A intersection B is empty. Kunyari lang ako, A and B is countable, meaning alam ko yung laman. Kunyari yung A is 1, 2, yung B is 3, 4. Countable yun kasi bilang ko eh. Tama? Pero nangyari, A intersection B is empty. Ngayon, ano ba bilang na empty? 0. Tama? So, alam natin na yung empty set is also finite. So, meaning, since finite siya, therefore, countable din siya. Okay, so mas madali malaman na siya ay countable pag intersection. Kasi, mas paliit eh. Yun ang kukuha. Common to 0 element. Okay? Next is number 3, countable unions. Countable unions of countable sets are countable. So ito naman, kung kanina intersection pinag-uusapan, ngayon naman union. Kung yung A and B is countable, yung union nila is also countable. Tandaan nyo. So, pwede naman namin kung A, B, C are countable, therefore yung union yung tatlo is also countable. So, paano kung ganito? A is countable, A is countable, B is uncountable. Ano yung A union B? Uncountable. Paano siya kung 2? A is countable, B is uncountable. Ano yung A intersection B? That is countable. Bakit? It's either may intersection yun or wala. Okay, so kung wala, so kung meron intersection yun, meron konti. Pero na lang, kung magiging intersection nun, is infinite pa rin. Pero sure naman ako na magiging intersection yun automatic. Countable yun siya, no? Tapos isa uncountable. So kunyari, magiging intersection yun, automatic talaga liliit eh. So parang literal siya ay countable. Okay, next number 4. Finite products of countable sets are countable. So, paano naman dito? Dito naman is yung cross product. Kunyari, A is countable, B is countable. Yung A cross B is also countable. Yun yung ibig sabihin niya. Okay, so, pakisulat na lang din. Kayo na bahala. Next, let's have further properties para mas maintindihan nyo to. So, further properties, every infinite set has a countably infinite subset. So, tama naman, parang ayun lang din siya. So, subset of countable sets are countable. Ito lang parang in general. So, pasok na dito yung pagiging finite. Dito naman, sa infinite set na. So, every infinite set has a countably infinite subset. So, for example, the set of real number, hindi natin alam kung countable or uncountable yun until now. So, pero ito yung sure ko. Sure ako na makakagawa ako ng countably infinite subset nun. Dahil sinabi countably infinite subset, meaning nagmamap dito. Okay, sandaan yung word na countably infinite, ginagamit natin yan pag infinite yung ipoprove. So, gagana si countably infinite pag nakapag-prove ka ng infinite set na nagmap sa natural number. Okay, so meaning, every infinite set has a countably infinite subset. So meaning, infinite siya, may subset siyang infinite set, pero countably. Okay, so countably infinite yun. Okay, next is number 2. Let S is countable, then S is strictly less than to natural number and N is strictly less than to natural number. Ayun yung sinasabi ko, other way. So, para masabi ko kung countable si S, magpakita na lang ako, or yung countable si set A ko. So, magpakita na lang ako ng S strictly less than, so strictly less than to natural number. This is if and only if there exists a function mapping from S going to natural number which is 1 to 1, and nagpakita ko ng si natural number is strictly less than to set S if and only if there exists a function mapping from natural number going to set S which is also 1 to 1. Okay, so pag napakita ko tong dalawang to, automatic countable na siya. Ganun kasimple. Or, ito lang, kunwari si set S is countable, pwede ko agad tawagin to. Kasi nga, sabi nga, no, if S is countable, dalawa ang bagay isipin mo. Pwedeng strictly less than to doon, strictly less than to dyan. Okay? So, tandaan nyo yung properties na yun. Okay, so let's have property number 3. So, let A be countable. So, if B is a subset of A, then B is countable. Ito nga yung sabi ko kanina. So, kung yung superset is countable, automatic si B is countable. So, ngayon, paano natin ipoprove yan? Okay, so, ano ba goal natin dito? Kasi ito yung proof. Ay, natin dito. Okay, so, ang goal, si B is countable. Our goal is B is countable. Okay? So, labas natin muna dito exclude muna natin yung pop na siya ay finite. Okay? So, i-exclude muna natin yung pop na si B is finite. So, include muna natin or isipin natin na si B is infinite. So, what if si B is infinite? Ipasok natin sa isip kasi mas maganda, in general, mas marami natin si proof. So, para malasabi natin na B is countable, this implies or that is B is numerically equivalent to natural number, or by symmetric property ng equivalence, this is natural number is equivalent to B. Okay? So, kailangan natin makapaglabas ng function mapping from either sa dalawang yan. Tapos, dapat bijective. Okay? Ngayon, since A, so, alam natin, since B is a subset of A, so, aware ako dito, no? Since B is a subset of A, okay, so this implies that there exists an injection F mapping from B going to A. So, sir, ano yan? Tama ba yun? Sabi subset eh. So, since subset siya, okay, so aware ako na, di ba, may parang may sinabi ako last time na pag subset ako, makakapag-create din ako ng function mapping from there. Pero 1 to 1 lang. Ayun lang yung sure ko. Basta subset ako. Okay, mapping from subset going to superset. Okay, alam ko parang nasabi kayo or something about sa mga theorem. So, nakalimutan ko ng theorem siya. Okay, so ulit ko lang, since B is a subset of A, so there exists an injection mapping from, there exists an injection F mapping from B to A. So, again, 1 to 1 na yan. Okay, ngayon, alam natin si A is countable. Also, dito, also A is countable. Okay, ngayon, since A is countable, this implies, sir, ang sabi mo, sir, pag countable ang A, merong tayo nag-exist na numerical equivalent mapping from A going to natural number. Okay, so numerically equivalent siya kay natural number. And ano ibig sabihin nito? This implies na, diba sabi ko, no, by property number 2, ano sabi ng property number 2? Pag ako ay countable, pwede kong sabihin either sa dalawang yan. Okay, so by property number 2, by property number 2, we can say this implies that A is strictly less than to natural number, which is there exists a function, let's say G. So let's say G, there exists a function G, okay, mapping from A going to natural number, which is ano ba magandang tawag, which is 1 to 1. Okay, so yun, tinawag ko lang isa by property number 2 since numerical equivalent naman sila. Ngayon, tingnan nyo meron akong function mapping from B going to A and function mapping from A going to natural number. Ang goal natin that makapagpalabas tayo ng ganito. It's either sa dalawang yan. Okay, so magdi-define ako ng function. So, define lang natin na function. Define, let's say H. define H, B equals sa G circle F. Okay, so what is G circle F? G circle F is a function mapping from B going to natural number. Kasi B going to natural number. B, A, N. So, mapping B from N to natural number. Ngayon, meron tayong theorem last time, no? Sabi ko, if F is bijective and G is bijective, therefore, G circle F is bijective. Okay, or G compose F is bijective. Okay, so this is, so G circle F, if F is injective, and G is injective, therefore, yung G circle F is injective. G circle F is injective by theorem. Hindi ko na alam kung ano number yung theorem na yun dati. Okay, since G circle F is injective, ngayon, nakahanap ako ng function. So, there exists a function, siya nga si H, okay, mapping from my set B, going to natural number, which is 1 to 1. Tama. Ngayon, by theorem 1.11, kasi nga nakahanap ako ng injective, therefore siya ay countable. So by theorem 1.1, so again by theorem 1.11, okay, so we can say automatic that B is countable. Okay, and we can say that this is done. Hindi pala siya kasya, napakahaba pala. Okay, so nakalimutan ko yung number na yan. So ulit, nakita ko na function na injective, isang function na injective, therefore yung composition nila injective, alam natin yan. Ngayon, since nakita ko na function which is just H, G circle F, okay, ngayon na B mapping to natural number which is 1 to 1, therefore by theorem 1.11, B is automatic countable. Ganun kasimple lang yun. Okay, so ayun yung mga tulong ng theorem. So instead na i-prove mo pa ng surjective, tapos na ako ngayon. Okay, next is if A and B are countable sets, then A union B is countable. So ito nga yung sinabi ko kanina sa kanilang property, this is ang theorem, no? Pero yun naman countable union meaning ito dalawa lang. Doon sa isang property sa theorem, marami yun . So pwedeng A union B, union C, union D, union F, basta as long as lahat sila countable, therefore countable yung union ng lahat. Okay, so dito naman, para naman po yun dito, sir. So number 4, so if A and B are countable sets, then A union B is countable. Okay, so ano ba yung mga pwede natin gawin dito? So aware ako sa A and B are countable. Okay, so ito yung proof. So since A, lagay ko lang dito, no? Since A and B are countable sets. Okay, by property number 3 ulit. So this implies by property number 3, A is strictly less than to natural number and B is strictly less than to natural number, or A is numerically equivalent to natural number and B is numerically equivalent to natural number, pwede rin. Pero dito nga tinawag ko lang property number 3. By property, nalilito ako sa property number 3. Okay, so sir, bakit yan yung gagamitin mo? Kasi mas madali yung way na mapalabas ko siya na 1 to 1 tapos tawagin ko si theorem 1.1. Ganun kabilis Sabi kayo doon. So napansin nyo, no, mas ginagamit ko si theorem 1.11 kasi mas mabilis So makapagpalabas ka lang ng injective, automatic numerical equivalent na sila. Okay, so ngayon, ang ibig sabihin nito, kung meron yan, there exists different function. So there exists function, let's say there exists a function F. There exists a function F mapping from A going to natural number, and there exists a function G mapping from B going to natural number. So ito hindi natin pwede i-compose. So sir, bakit hindi pwede? Kasi pag kinompose natin G circle F, hindi sila magbi-bridge. Hindi, unlike dito, nag-bridge. Kasi B, A, A, B. So nag-bridge yan. B, A, A, N. So nag-bridge siya A. So yung range nito, yung codomain niya, is equal sa domain ng G. Kaya nagbe-bridge. Kaya nakuha natin B implies N. Dito hindi. Hindi ka pwede kumuha or maglabas ng composition ng dalawang function. Kasi nga, wala i-bridge. Okay, sir, paano kung ganito? Pumunta dito, pumunta dito. Hindi rin. Kasi B going to N, tas A going to N. Hindi pwede. Kasi hindi natin alam kung ano yung A mismo. Okay? So, ngayon, ano sir ang gagawin natin? Gagawa ako ng function in which yung A union B yung kailangan natin. Kasi yun naman talaga yung kailangan eh. Okay, so ang goal natin, makapaglabas tayo ng function mapping from A union B going to natural number. So define natin. So let us define. So define H to be a function mapping from A union B going to natural number by. So paano ba natin gagawa na sure ako lagi siyang natural number? So, ito yung sure ko. Gagawa na lang ako ng function arbitrarily na kung saan nagmamap siya sa dalawang bagay. Add or even. Okay, so ulit ko lang ha. Gagawa ko ng function since hindi ko alam yung element ng A union B. Hindi ko alam yung element ng A and B kasi hindi ko alam yung dalawang set na yan. Ang alam ko lang sa kanilang dalawa, sila ay countable sets na kung saan may function nag-exist. Na pareha silang which are both 1 to 1. So, yun lang alam ko eh. 1 to 1 lang yung dalawang yun. Okay, ngayon, ang goal ko na lang din, since alam ko 1 to 1 yung dalawang yun, sir, hindi po rin pwede sabihin na A union B 1 to 1. Yes, kaya nga gagawa ko ng function. So, ito yung gagawin ko. Gagawa ko ng function na kung saan ibabalik at ibabalik niya, tapos paulit-ulit yung parang recursive siya. Kunyari, so, such that h of x ganito. Gagawa ko ng function, tapos siya ay piecewise. Okay, una, siya ay 2 h of x plus 1. Pangalawa, 2 h of x. So, whenever dito, si x ay element of A, whenever dito, si x element ng B minus A. Okay, sir. Anong ginawa mo, sir? Ginawa ko, pag yung x element of A, yung h of x is 2h of x plus 1. So, in nature, siya ay add. Okay, so, in positive nature natin, siya ay always add. Okay, ngayon, kung yung x hindi naman, kung si x is element of B minus A, so disregard natin yung common nilang dalawa. Okay, so meaning ako yung element ng B na wala kay A, ako ay even. So, ayun yung ginawa ko. So, ngayon, ano nangyari? Kada input ko ng element na galing sa A and B or sa A union B ko, ano nangyari? It's either add or even. So, regardless kung nasa ang position siya, regardless kung nasa A man siya, or nasa B, or nasa common, or nasa intersection nilang dalawa. So, sure ako, na lagi yan nagmamap sa natural number. Kasi lagi lang yan add or even eh. Okay? So, this implies that H, mapping from A, union B, mapping to natural number, is 1 to 1. Tama? Kasi sure ako eh. Without proving it, sure ako dyan yung claim ko na yan. Lagi yung even or add. Yun na yung pupuntahan niya. Yun. Since nasabi ko na siya ay 1 to 1, by theorem ulit. So, by theorem, 1.11, since alam ko na siya ay 1 to 1, meron na function na nag-exist going to my set, going to natural number. Kasi yun yung goal ko eh. Dapat sa A union B is countable. Therefore, A union B is countable. Okay, and this is done. So, hoping na nag-gets mo yung idea kung paano ko tinatawag si definition, si theorem, or si what. So, kung napansin mo, ang dami nating alam. So, ito nga rin yun eh. Ito nga rin yung may kita ko eh. So, talagang nanonood ka, naiintindihan mo from the very beginning ano ba yung mga sinasabi ko. Kasi, hindi ko ipoprove or hindi ko ilalabas lahat ng sinasabi ko doon kung hindi ko gagamitin, kung hindi mapapakinabangan. Okay, so this is a theory. Set theory is all about imagination. So, deeper imagination to. So, malayong malayo to dun sa high school na alam mo. Okay? Okay, next is number 5, property ulit. If A sub 1, A sub 2, A sub n are countable sets. So, mga A siya, no? So, sila are all countable sets. Ito na yung marami. Okay, so for letter A, the generalized union. So, word dyan is generalized union. So, ibig sabihin ng generalized union from I is equal to 1 up to n ng A sub I. This is equivalent sa A sub 1, union A sub 2, union A sub 3, union ... union A sub n. Okay, yan sabi nga, kung yung mga element o yung mga sets na yan are countable sets, Therefore, ano yung union? O yung generalized union? Therefore, this implies this is countable. So, property yan. So, mas maraming union, countable pa rin sila. Next, yung generalized intersection ng mga A sub I for I is equal to 1 up to N. Pansinin? Ito, ang ibig sabihin, this is A sub 1 intersection A sub 2 intersection A sub 3 intersection ... intersection A sub N is also countable. So, aware kayo dyan. So, bakit sir? Ang nangyayari pag intersection, it's either lumiliit yung element or yung cardinality ng set ng intersection nila or nagiging empty, which is parehas finite or zero. Tama, zero yung naman. So, finite din pala yun. So, tama yun. Next is N cross N. So, N cross N. So, imagine mo, N cross N is numerically equivalent to N. So, meaning, countable to. No? So, meaning, sir, yung N cross N, countable. So, isip ka, sir, bakit? Okay, ngayon, syempre, ang goal natin, magde-define tayo syempre ng function na kung saan magmamap dyan. So, gagawa ka ng function, syempre, paano ito gagawin? Para maging numerical equivalent. So, hindi natin goal na sabihin countable property siya So, ang goal natin, kailangan mapakita natin na siya ay numerically equivalent. So, kailangan may mag-exist na bijective function, mapping from N cross N going to N, or may mag-exist na function mapping from N cross N going to N and N going to N cross N. Ayun yung mga goal or scenario na habulin natin. Okay, so since numerically equivalent yung proof natin, gagawa natin ng function. So ito yung proof. Okay, so una, ang goal natin, so define a function f. Define f to be, unahin ko muna to, N mapping to natural number cross to natural number. Okay, ito yung una. So, define f such that f of n is equal to n. So equal to n comma n. So, check natin kung siya ay injective. So, f of n is equal to n comma n. So, pag input ko ng n, nagiging 1 to 1, nagiging coordinate siya or something. Okay, so dito, let natin, so let x sub 1 and x sub 2 element of natural number. Okay, so this implies that f of x sub 1 is equal to f of x sub 2, which implies that x sub 1 comma x sub 1 is equal to x sub 2 comma x sub 2, which implies that x sub 1 is equal to x sub 2. Kasi ganun mangyari. Coordinate nito equal sa coordinate nun, second coordinate equal sa second coordinate, which is 1 to 1. So, f is 1 to 1. Since f is 1 to 1, we can say that n is strictly less than sa natural number cross natural number. Okay, so hindi pa tayo tapos. Next is syempre gagawa ulit tayo ng function. So define a function. So define. So again a function, let's say g naman. Let's define a function g mapping from n cross n going to natural number. Okay, so sir, anong klaseng function? So sabi nung nag-google ko kanina, kasi ngayon ko lang din pinrove to. Sabi nung nag-google ko, ang maganda to function para dito is g by g of x comma y is equal to 2 raised to x 3 raised to y. Okay, so from coordinate nagiging ganyan. Okay, so ano yung mga element ng x and y? There are both natural number. So 1, 2, 3, 4, 5. Nandiyan 1, 1, 1, 2, 1, 3. Wala dyan 0. Wala negative. Laging positive number or real number. Positive, I think, integers. Yun. Okay, so ngayon, show natin na siya ay 1 to 1. Okay, so we need to show na ito ay 1 to 1. So, syempre, mag-let ako. So, let A, I think dalawang value. So, ito na lang, no? Let natin na si X, Y, and si A, B, element nung N cross N. Okay, so ang goal natin, mapakita natin na si G of X, Y, si G of A, B, dapat napakita natin na si X is equal to B, Y is equal to B. Ayun yung unang gagawin natin. Okay, so this implies that this is 2 raised to X, 3 raised to Y is equal to 2 raised to A, 3 raised to B. Okay, ngayon, ang gagawin ko, pagkasamahin ko yung may base na 3 saka base na 2. So, dadalhin ko yung 2 dito sa kabila, dadalhin ko yung 3 doon. So, ang mangyayari, this is 2 raised to X over 2 raised to A is equal to 3 raised to B over 3 raised to Y. Okay, which implies na magsimple by property exponent, this is 2 raised to X minus A is equal to 3 raised to B minus Y. Okay, so ngayon, kunin natin yung scenario na ito. Case 1, kasi dalawang magiging case, no? Hindi natin agad pwede sabihin na equal yung dalawang yun eh. Okay, para masabi natin equal yun, dapat equal din to, yung dalawang to. So for case 1, lagay ko dito, case 1, consider natin itong side na to, yung X minus A. Case 1, if X, let natin, if si X minus A is less than 0, so tama naman, no? Kung, wala 1 to, tapos 2 yung A, 1 minus 2 is negative 1, so less than 0 yun. So kung less than 0 yun, therefore si 2 over X minus A, this implies that 2X minus A, ano magiging value nun, no? Yung 2X, yung 2 raised to X minus A, imagine mo kung yung X minus A is less than 0, that is negative yung exponent. Meaning, kung negative yung exponent, that's gonna 2 raised to negative 1, 2 raised to negative 4. So, automatic, yung 2 raised to X minus A is less than 1, which is not an element of natural number. Tama? So, automatic. Another case, kung i-delete natin ito, kung ulit din natin na si B minus Y is 0, same din. Si 3 raised to B minus Y is less than 1, which is not also an element of natural number. Kaya yun nangyari. So, kung less than tong 0, less than din tong 0, para silang less than negative 1, which is not an element of natural number. So, observe yung case na yan. Okay? E what if ganito? Case 2. Sir, what if i-let natin na si X minus A is greater than 0? Okay, so, ang sure ko dyan, if X minus A is greater than 0, ang sure ko, this implies na yung 2 raised to X minus A is even. So, isip, sir, bakit? Kunyari, X minus A, kunyari, that is 2 raised to, kunyari, 2 and 1 yun. So, 2 minus 1 is 1. So, 2 raised to 1 is 2, even. Kunyari, 3. 2 raised to 3 is 8. 2 raised to 16. 2 raised to 6 is 64. 2 raised to 5 is 32. Always even yan. Sure ako. Okay, likewise, ano mangyayari? So, kung even to, ano masabi mo sa kabila? Even din ba to? So, check natin if. So, kaya ba? Sabi nga, equality holds eh. So, kunyari, even na to. Ano masabi mo dito? Sir, always dapat even to. Okay? Sir, this implies na si 3 raised to B minus Y, kasi nga equal sila, sabi dito, sa function na to. Sabi sa nakuha natin. If ito even, since sabi equal sila, dapat ito even din. Okay, yun yung sure ko. Since that if 3 raised to B minus Y, this is even. Okay, sir, bakit siya even? Magiging even siya pag yung B minus Y is 0. Or pag since B is equal to Y. Ayan, i-check natin So, in any case, pag case 1, pag less than 0 sila, automatic sila ay hindi pasok dito sa case natin. So, observe yung case na to. Ngayon, pag ito yung case, automatic, nagiging equal. So, kunyari, when x minus a is greater than 0, alam kong even to. Ngayon, kung even to, sure ako even to. Kailan magiging even to? Magiging even yung 3 raised to b minus y is even pag yung b minus y, pag b is equal to y. Kasi, 3 raised to 0 is magiging even, sorry 3b minus y. Napaisip tuloy ako, wait. Okay, so nakita ko na, no? So, ulitin ko lang. So, if x is greater than a and greater than 0, then this implies that yung 2 raised to x minus a is always even. Ngayon, since alam natin na even to, dapat even din to. So, this implies na yung 3 raised to b minus y is even. Pero, since b minus y is greater than 0, anong mapapansin mo kay 3 raised to b minus y? Since greater than 0 siya, that is 1, 2, 3, 4, 5, 6. Kasi nga, yung mga x and y, yung b, y, x, and a na yan is always natural number. So, ito is always add. Kahit nga b minus y is 0, 3 raised to 0 is 1 So, this is always add. Which is a contradiction para sa part na to. Okay, kasi ang claim So, meaning, yung nakuha ko na expression na to, itong expression na to, is hindi isa-satisfy yung pagiging 1-to-1 niya. Meaning, hindi natin kailangan dalhin dito expression in which dito lang tayo dapat. Ngayon, kailan mangyayari na yung 2 raised to x and 3 raised to y is equal to 2 raised to a, 3 raised to b ay equal? Mangyayari yon pag yung x. So, mangyayari tong case na yan pag yung x equal sa a and yung y equal sa b. Ganun lang, sa case lang na yun. So, ibig sabihin, pasok lang to pag ang mga element na ginagamit natin, yun ay 1, 1, 1, 1. So, dun lang siya. So, pasok lang siya sa case na yung mga element is parang reflexive. Okay? Yun yung sinasabi niyan. So, meaning, this implies that x, y is equal to a, b. Strictly, pag reflexive lang yung element. So, meaning, purely reflexive lang, kunyari 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Ganun kasimple. Or, I mean not reflexive. Kunyari same ng element. Kunyari 1, 2, 1, 2 rin sa kabila. 1, 3, 1, 3 rin sa kabila. Okay, so sa kanya mismong element na naglalaro. Okay, so in this case, we can say, so, G is 1-to-1. So ngayon, ano purpose? Bakit pinakita mo to? Nag-generate kasi ako ng function na to. So, itinry natin kung dito mapaprove natin na equal ba yung x sa a, equal ba yung b sa y. Okay? So, anong nangyari nga lang, hindi natin magawa Okay? So, tingnan nyo, pansinin nyo. Ito, another lang. Kaya ko lang dito sabi na x equal to a and y is equal to b. Mangyayari lang kasi na totoo yung 2 raised to x minus a sa b sa is equal to 3 raised to b minus a. Pag yung x minus a, mangyayari lang to pag si x minus a is equal to 0 and si b minus y is equal to 0. Bakit? X minus a is equal to 0, that is x equal to a. B minus y is equal to 0, that is y is equal to b. Tama. So, ayun yan. Pag even or add, pag greater than or pag less than or greater than 0, hindi mangyayari. Pero pag equal, dun lang. Kaya ito yung sinabi ko. So, G is 1-to-1. Therefore, n cross n is strictly less than n cross n. By SB, kung naalala mo yung SB, by Schroeder-Bernstein theorem, we can say that n cross n is numerically equivalent to n, and that is done. Tama. So, buti naisip ko yung reason about dyan. So, let's have a property. So, if A is numerically equivalent to B, then yung power set of A is numerically equivalent to B. Ito yung number 7. Number 8, if A intersection B is equal to empty, then yung power set ng A intersection B is numerically equivalent sa power set of A cross power set of B. So, imagine mo kung empty to, ang laman ng power set ng A cross B is empty sa kanan empty in the set containing empty. Tapos numerically equivalent pa pala sila dun. Tama naman kasi kaya ko mag-create ng function na mag-map dun sa lahat ng element dun. Okay, next is R is uncountable. So, ayun na nga, 9, R is uncountable. So, hindi ko ito ipuprove ko to sa next video. Next 10, Q is countable. So, dun sa next video, ipuprove ko siya. Okay, so hoping na manonood ka pa. Then, sana sundan mo yung next video natin kasi mas importante. Kasi doon naman tayo mag-prove ng mga uncountable sets. Mag-prove tayo ng countable sa uncountable sets doon.